gentlemen, dear colleagues, thank you for giving me the chance to present my group's research in this online lecture series organized by Professor Naheem Jo at Konkuk University. The theme of the series, Ancient Northeast Asian History, Culture, Ethnic Origins and Interrelationships, is of great importance, not only to scholars from Japan, Korea and China, but to scholarship across the world. In my talk on linguistic, cultural and ethnic origins in Northeast Asia, I will take an interdisciplinary perspective, integrating archaeology, linguistics and genetics in a single approach. Over the last decade, the triangulation of these three disciplines has been revolutionizing our view of the human past. So this is the outline of my talk today. First, I will introduce the so-called Transeurasian languages, that is Japanese, Korean, Tungusic, Mongolic and Turkic languages. And then I will make some linguistic inferences about the linguistic origins of these languages. Next, I will explore what archaeology can tell us about agricultural expansions across Northeast Asia. And then I will turn to genetics, genetic inferences, presenting our analysis of ancient human DNA from the Neolithic onwards. And finally, I will bring these different lines of evidence together in an approach which we call triangulation. This will give us a richer and a more balanced understanding of the prehistory of Northeast Asia than each of these disciplines can provide us with individually. So I use the term Transeurasian in reference to this large group of geographically adjacent languages stretching from the Pacific in the east to the Baltic, the Mediterranean and the Black Sea in the west, and including up to 5 non-controversial linguistic families. So here we have Japonic in purple, Koreanic in yellow, the Tungusic languages in red, the Mongolic languages here in blue, and here we have the Turkic languages in green. The question of whether these 5 groups, Japonic, Koreanic, Turkic, Tungusic, and Mongolic, descend from one single common ancestor called Proto-Transeurasian, even if a part of the past support for Transeurasian affinity is indeed questionable. In my past research, I have shown that there is a small core of reliable evidence that allows us to classify these Transeurasian languages as a valid genealogical grouping. Accepting that the Transeurasian languages are genealogically related, however, inevitably gives rise to new questions, such as who were the speakers of these ancestral Transeurasian language, where did they live and when did they live, and why did they move and how did they reach their present-day locations. These questions cannot be answered by linguistics alone, as they reach into other scientific disciplines such as genetics and archaeology. Therefore, my archaeolinguistic research group addressed these questions by bringing the linguistic evidence together with the archaeological and genetic findings in a single approach, for which we use the term triangulation. In the linguistic part of our project, we collected the most comprehensive Transeurasian lexical database produced to date for all 98 Transeurasian languages, including contemporary and historical varieties. So our database includes basic vocabulary as well as agro-pastoral vocabulary. We applied Bayesian methods to infer a dated tree, a dated phylogeny of the Transeurasian languages. We find this tree structure that goes back to a root that is situated around 9,000 years ago. The tree splits first in a Japano-Koreanic branch and an Altaic branch. We reserve the term Altaic for the unity of Turkic, Mongolic, and Tungusic languages. And then in the Altaic family, Turkic is the first to split off, whereas in the Japano-Koreanic family, Japonic and Koreanic separate around 5,500 years ago. Using Bayesian phylogeography for the first time and complementing it with classical approaches, we also modeled the expansion of the Transeurasian language in space. So here you see how it was situated in the West Liao River region. And first, the Transeurasian family split, as you will see in the animation when we wait for the next animation to start up. We here see how Japonic and Koreanic split into Altaic and Japano-Koreanic, how Turkic is then the first to split off from Altaic and to leave in the eastern steppe. And then we see Koreanic moving first to the Korean peninsula. And Tungusic, about 1 millennium later, goes to the Russian Far East. And then we see how Japanese is the last to move over the Korean peninsula to Kyushu on Japan, from where it spreads over the rest of Japan. So we have an idea of the dating of the family and the location of the homelands. But we can also reconstruct the cultural and the natural environment of the speakers of Proto-Transeurasian. Examining the reconstructed vocabulary of Proto-Transeurasian, we find some agricultural words, inherited words related to field for cultivation, here cooked cereal and barnyard millet, so millets, but no rice or other crops. We also find some other agricultural terms like a verb here to cultivate and a tool, namely a hoe. And then we find etymologies that refer to fermentation, like here verb to ferment, or a verb that can be reconstructed as preserved food by fermentation. And there's also inherited textile technology from Transeurasian, such as here the verbs for spinning and weaving. So this indicates that the Transeurasian ancestors in the Neolithic were sedentary, practiced millet cultivation, preserved food by fermentation, and engaged in complex textile technology. Surprisingly or not, there are no cognates reflecting familiarity with secondary crops such as rice, barley, wheat, or pastoral vocabulary such as domesticated ruminants or horses or dairying terms. So we can infer that the ancestral speakers of Transeurasian in the Neolithic did not engage in the cultivation of rice, barley, or wheat, nor in pastoralism or dairying. Words related to the cultivation of rice, barley, or wheat can all be traced back to borrowings in the late Neolithic and Bronze Age. Here I illustrated the borrowing for the word for rice, which may be a borrowing over Para-Austronesian from Semitic. This may be seen in the context of prehistory contacts between Japonic and the sister language of Proto-Austronesian at a time when both language families, Japonic and Austronesian, were still situated in the Shandong-Liaodong area. Another borrowing chain that goes all the way from the west to the east relates to secondary crops, barley and wheat. Here we propose a borrowing from Tocharian, probably Tocharian because we have this Indo-European root Mrak, over Western Tibeto-Burman into Semitic and then into Tungusic, and from there independently in Koreanic and Japonic. So that's the Japanese term mugi for wheat and barley. And then there are other borrowing chains going from west to east. For instance, here, the word for horse that probably came from Indo-European into Old Chinese, into Mongolic, into Tungusic, and from Old Chinese probably independently in Koreanic and Japonic. So far, our linguistic inferences about time, space, migratory dynamics, and subsistence patterns. But how can we fruitfully interact with geneticists and archaeologists? The most crucial issue, in my view, is the independent collection and analysis of data. Here you see our geneticist and archaeologist in action. Our geneticist Ning Chao at his site in Banlashan in northeast China, and here at another site at the Yellow River, and then Chung Won-jong, with whom I went collecting this Bronze Age Korean skeleton for DNA extraction. And then our archaeologist Mark Hudson at his site in Miyako, named Nagabaka. In the archaeological part of our project, led by Mark Hudson, we used a wide-ranging archaeological database of 255 Neolithic and Bronze Age sites, dating between 8,400 and 1,700 years ago. Our sites cover northern China, the Primoria, Korea, and Japan. So the Bronze Age sites here are marked in green and the Neolithic ones in red. We scored all these sites for 172 features, including ceramics, stone tools, buildings, plant and animal remains, shell and bone artifacts, and burials. We also compiled an inventory of early cereal remains with direct radiocarbon datings. We applied computational Bayesian methods on our data sets, but also classical qualitative analysis. And the Bayesian methods helped us to infer clusters of similarity. And these clusters of similarity are indicated with colored dots on the map, corresponding to the clusters here in the Bayesian analysis. We find the first cluster of Neolithic cultures going back here to the West Liao River area. And from there, we see two branches branching off. We have this pink branch corresponding to the Chumon cultures. And then we have this blue branch corresponding to the Neolithic cultures here on the Shandong and the Liaodong Peninsula and in the Amur. So this confirms earlier findings about the spread of millet. We know that millet originated in the West Liao River area and was first brought around 6,500 years ago to the Korean Peninsula, and then about 1 millennium later it dispersed to the Russian Far East. A second cluster in our Bayesian analysis then is this green cluster with some Bronze Age cultures here in the West Liao River area in dark green, and the others that is the Mumun cultures on Korea and the Yayoi cultures on Japan in light green. This cluster of similarities supports the integration of rice to the millet agricultural package. We know that rice traveled from this Shandong-Liaodong interaction sphere over Korea to the southern tip of the Korean Peninsula, and from there it was imported to Japan around 2,900 years ago. And then third, we also have a genetic part to our project. In the genetic part of our project, led by Chowning, we sampled genomes of ancient individuals from the Amur, Korea, and Japan. And we added pre-existing studies from the Primoria, the Yellow River region, and here the Eastern Steppe. All our samples range between the early Neolithic, that is around 9,500 years ago, and the Middle Ages, that is around 300 years ago. So we took these ancient genomes and we projected them on top of a principal component analysis of present-day Eurasian populations. So this shows that the prehistoric hunter-gatherers from Northeast Asia, here marked in wine red, along with the early farmers of the West Liao River region, here in wine red, the squares, and also these Amur populations from the Neolithic, they all cluster together on top of contemporary Tungusic populations, which are here marked in yellow. So we call this cluster of shared genome Amur ancestry. And this Amur ancestry is the common component for all speakers of Transeurasian languages. We find it not only in the Tungusic populations here marked in yellow, but also in the Mongolic speaking populations here marked in orange, and the Turkic speakers here marked in gray, be it with an increasing degree of west-east admixture, so pulling the genomes more to the west. This Amur genome is also clearly present in the Korean-speaking and Japanese-speaking populations. Here we see an admixture plot, and our team can report the first ancient genomes from the Korean Peninsula. It is surprising to see that ancient Koreans reflect Jomon ancestry, here marked in blue. Jomon ancestry, of which we previously thought that it was only present in Japan. So our study allowed us to really extend this surface to also cover Korea. The middle Neolithic genome in Korea is clearly a mixture between this blue Jolmon genome and a brown genome that corresponds to the Hongshan genome, which you see here. So this Hongshan component is the brown component. This suggests an eastward gene flow from the West Liao River area from northeast China into Korea around the time of the adoption of millet agriculture. Then we see that the Korean Bronze Age genome is significantly different from the Korean Middle Neolithic genome, and that it can be modeled as Upper Shajajen genome, so suggesting a second wave of gene flow from northeast China into Korea, probably with the adoption of rice agriculture. And then we see that this Korean Bronze Age genome is strikingly similar to the Japanese Bronze Age genome, the so-called Yayoi genome, which suggests a massive influx from Korea into Japan. In Japan, this led to a genetic turnover of the underlying Jomon genome here in blue to this Yayoi genome. Interestingly, we found Jomon genome as far as the southern Ryukyu, so also on Nagabaka, the Jomon, the genome was completely Jomon, and we did not find any influence from Austronesian populations on Taiwan whatsoever. So this brings us to the triangulation of our evidence. Bringing together languages and millets and genes, we find some correlations in the evidence. We situate our Proto-Transeurasian speech community here in the West Liao River area around 9,000 years ago, and it was not only geographically adjacent, but also more or less contemporaneous to the Sino-Tibetan speech community that has been situated here in the Yellow River area at around the same time. This division of the locations of Proto-Transeurasian and Sino-Tibetan is nicely mirrored in the location of two distinct centers of millet domestication in the Neolithic. Here in the West Liao River region, we find a center that was focused on broomcorn millet domestication, and here in the Yellow River region, one that was focused on foxtail millet. And in parallel, we also find this genetic picture whereby we find a large gene pool of Amur ancestry reaching all the way from the Baikal to the Russian Far East, including the West Liao River area and the Korean Peninsula, against this green gene pool of Yellow River ancestries. Then the primary split between Transeurasian was into Altaic and Japano-Koreanic in the period between 9,000 and 5,500 BP. Although we do not find any evidence for dispersals at that early time, we do see that we do see increases in the population, suggesting that the people grew and that there was probably some environmental or social separation between groups, leading to a disconnection between Altaic and Japano-Koreanic speakers. And then between 5,500 and 4,000 years ago, we first see that Koreanic splits off from Japonic and moves to the Korean peninsula, and that about 1 millennium later, Tungusic splits off from Proto-Mongolic and moves to the Russian Far East. And this is nicely mirrored in the dispersals of millet agriculture, first going over the Liaodong Peninsula to the Korean years ago, and then 1 millennium later, millet disperses is also reflected in our genome. As we indicated, the Middle Neolithic Korean genome has this brown Hongshan component, the Hongshan being the farmers in the West Liao River region in the Neolithic, and this brown component suggests an influx here of a gene flow here from the West Liao River area, so from northeast China into Korea. And then finally, in the linguistics, we see Japanic moving from the Liaodong Peninsula to the Korean peninsula, and then over Korea to Kyushu on Japan. And this dispersal nicely reflects the dispersal of rice agriculture from the Shandong-Liaodong interaction sphere over the Korean peninsula to Kyushu. It is also reflected in the genome, as the Bronze Age Korean genome can be modeled as Upper Shajajen genome, or thus suggesting a second wave of gene flow from northeast China into Korea. And then this Bronze Age Korean genome is very similar to the Yayoi genome, suggesting massive gene flow from Korea into Japan, leading to this genetic turnover of the blue Jomon genes to the brown Yayoi genes. So bringing together everything in one picture, this map integrates our linguistic, archaeological, and genetic findings. It traces the origins of the Transeurasian languages to the beginnings of millet cultivation and the early Amur gene pool in northeast China in the Neolithic. The spread of the languages involved two major phases that mirror the dispersal of agriculture and genes. The first phase, here indicated in red, first brought Koreanic over the Liaodong Peninsula to Korea around 6,000 years ago, and then millet, together with the Tungusic language, dispersed about 1 millennium later to the Russian Far East. Then we see a second phase in the dispersal of the languages, here marked in green. It is a time where we see many contacts between Transeurasian languages, but also between Transeurasian and non-Transeurasian languages. The period is marked by the integration of rice agriculture with millet agriculture. And this green arrow brings not only Japanese to Japan over the Korean peninsula, but also together with rice agriculture and Bronze Age Korean genes. So in sum, ladies and gentlemen, our research challenges the traditional pastoral hypothesis for Transeurasian origins by arguing that Proto-Transeurasian was the language of the first farmers in the Liao River area around 9,000 years ago. As such, our research brings the case of the Transeurasian languages into line with the farming language dispersal hypothesis, which posits that many of the world's major language families owe their primary dispersals to the adoption of agriculture by their early speakers. In doing so, our research also relates an episode of a population expansion from the Liao River region into neighboring areas to the shared ancestry of hundreds of millions of living people in the world today. To lift a tip of the veil, we used an interdisciplinary approach to the understanding of the linguistic prehistory of Northeast Asia. But it is only a tip of the veil that is lifted so far. So, ladies and gentlemen, thank you for your attention.